These are the practice problems from Unit 2, Lesson 10. This first one is really similar to the one from Unit 2, Lesson 9. Um, it tells us that Tyler has proven that triangle WYZ is congruent to triangle WYX. And it says that he used the side, side, side triangle theorem to prove this. So we have our proof and our reasoning. Now, remember I said in the last set of practice problems that when we see this, usually the next thing we're going to see is CPCTC if you want to prove that two corresponding parts of the two triangles are congruent. So we know he already did this, right? Because we know he used side, side, side. So now they want to know why he can conclude that the diagonal WY bisects angles ZWX and ZYX. So that means he wants us to tell that this angle is congruent to this angle. I'm doing 4 tick marks because we already have, oh, actually, no, we don't need to do that. Sorry, because my other tick marks are for the segments. So I can just do 1 here. Okay, so this one is congruent to this one. This one is congruent to this one. That's what we're trying to prove. And he already can prove that because since he said that the triangles are congruent, we know that angle XWY is congruent to angle ZWI because corresponding parts of congruent triangles are congruent. We can also do this other side up here and say that angle XYW is congruent to angle ZYW because corresponding parts of congruent triangles are congruent. So once we have both of those, then we know that WY is a bisector of the big angle because if this part is the same as this part, then this line is bisecting that bigger angle. If you click show me a sample response, you can see it written out in word form. Practice problem 2. Okay, so this one, we're just going to fill in these blanks here. We're going to talk about it. Elena is thinking through a proof using a reflection to show that the base angles of an isosceles triangle are congruent. Complete the missing information for her proof. So we're just going to read the sentence and see what goes in there, right? It says, call the midpoint of segment CD what? So this is segment CD, so we're calling that midpoint B. It's just written there for us. We're just putting it in. Construct the perpendicular bisector of segment CD. The perpendicular bisector of CD must go through B since it is the midpoint. So we can see that it does. A is also on the perpendicular bisector, on the perpendicular of CD because the distance from A to blank is the same as the distance from A to blank. So we know that the distance from A to D is the same as the distance from A to C because it tells us that those two are congruent. We want to show triangle ADC is congruent to triangle ACD. Reflect triangle ADC across line. Okay, so what line are we going to reflect it across? So ADC is the big triangle, right? So if we reflect it across this center segment AB or line AB, then it's going to look like it stays in the same place, but C will now be over here, D will now be over here. So it says, since blank is on the line of reflection, it definitely lines up with itself. So since segment AB, right, or angle A, either one, or segment AB, is on the line of reflection, it lines up with itself. DB is congruent to blank. I'm going to have to scroll down and it's going to mess up what I wrote so far. So just, you can rewind if you need to see what I wrote so far. The next part says DB is congruent to blank since AB is the perpendicular bisector. So we know DB is congruent to CB since AB is the perpendicular bisector of CD. D prime will coincide with what? That's what we just said, right? D prime, when we flip it, D prime is going to be over here. So D prime will coincide with C, since it's on the other side of the perpendicular line and the same distance from it. That's the definition of reflection. Since the rigid transformation will take ADC onto triangle ACD, that means angle blank will be taken onto angle blank. So what we're, these could be either, you could either say angle C will be taken onto angle D, or angle D will be taken onto angle C. So D will go to C, and C will go to D, because they're corresponding parts under the reflection, and therefore they are congruent. So after you fill in all your stuff, just go ahead and hit submit, and you'll also see another sample response. So some of these can have more than one answer. You can always rewind to look at those if you need to. All right, let's go on to the next one. So this is practice problem 3. And it just says to sketch your screen, mark your diagram with the given info, and be on the lookout for things that we talked about. You're going to make a plan, check the statements and reasons below that will complete this proof, and write them in the correct blank space in the proof. So we're going to check the reasons, see what we can do about it, right? So the first one, the reason is given. If the reason is given, we know that the statement has to be the given information. So it says M bisects segment AC and BD. So we know this one's going to be correct. The next one says AM is equal to MC, right here, and BM is equal to MD, and I'll just do it in a different color. Okay, and then we have to know what that is. So since it said it bisects a segment, that is the definition of bisector, because you always have to look at the previous thing to give the reason for the new one, right? So since we just said the statement before this was that M bisects, well, now we know these are equal because of the definition of bisector. So you have to kind of look at one and see how it leads to the next. Number 3, vertical angle theorem. Okay, so what are we going to say about the vertical angle theorem? So our choices here, we can either say, and we can look at our choices to help us, either ABM is congruent to CDM. That's this one and this one. Those are not vertical angles, so I can't choose that one. This one says AMB is congruent to CMD. That's these two. Those two are vertical angles. So that's what I'm going to choose. I'm going to erase these so they just don't get in our way. And then here we have a side, an angle, and a side on this triangle, and then up here on the top triangle we also have a side, angle, and a side. So that's how we're going to know what theorem we want to choose here, and side, angle, side, because that is what we have. So that's going to go by number 3. Then number 4 says triangle AMB is congruent. Oh, that's the one we just did, side, angle, side, sorry. Number 5 says angle BAM is congruent to MCD. We know right after we prove the triangle, most times it's CPCTC, right? So that's what we're going to choose. And then the last one, we have to choose whatever we're trying to prove. So we're trying to prove that segment AB is parallel to segment DC. If you don't choose, if that's not your last thing here, then you're not done. So whatever you're trying to prove has to be your last statement. All right, and you can check your answers after you do it. Try it yourself. Check your answers to see if you're correct. All right, let's move on. The next practice problem here, select all true statements based on the diagram. So if we look at this diagram, we're going to see what we think is true. This first one says angle CBE is congruent to angle ABE. CBE, ABE. Are these two congruent? Do we have any proof that these two are congruent? No, we don't. So we're not going to choose that one, right? Because the only things that we can see here doesn't say anything about those two angles being congruent. The only things we can see are what they give us, which is CD and AB are parallel, and AD and BC are congruent. So the next one says angle CEB is congruent to DEA. So we have CEB, DEA. Now, even though they didn't give us that information, we know those are congruent. We know they're congruent because they're vertical angles, and we know vertical angles are always congruent. So we can check that. The next one says segment DA is congruent to segment CB. DA, CB, yes, they gave us that one, so we can choose that one. The next one says segment DC is congruent to segment AB. DC is up here. AB is down here. Those are parallel, but they're not congruent. So we can't choose that. The next one says line DC is parallel to line AB. That's the one we can choose. That's what we know. And then the last one that says line DA is parallel to line CB. So that would be this one is parallel to this one. And obviously those are not parallel. We have no evidence of that. So these should be your 3 correct answers. If you hit submit, it'll tell you if you got it right. And in case you missed one, you can click that button and it'll explain it. All right, let's go to the last one. Practice problem 5. Okay, it says segment E. Let's go ahead and mark it while we read it. Segment EG is an angle bisector of angle FGH. FGH. So it says EG bisects FGH. That means that this angle here is congruent to this angle. So Noah has a proof. He's writing a proof. It's not correct, and we want to know why it's incorrect. So let's see if he used the correct logic here. So the first he said side EG is congruent to side EG because they're the same segments. That's this here. Yes, that's correct, right? Because it's reflexive. He didn't say that because he's just using his own verbiage, but we know that that's reflexive. Okay. The next one he says angle EGH is congruent to angle EGF because segment EG is an angle bisector of FGH. So that's what they told us up here. EG is an angle bisector of FGH. And that's the pink ones that we already drew here. So yes, that's correct. That's what they gave us, right? The next one says angle HEG. Let's go ahead and mark this. He's saying HEG is congruent to FEG. So he was saying this one is congruent to this one because segment EG is an angle bisector of FGH. Okay, so he's saying that these two up here are congruent because this line is an angle bisector of this angle down here. So that's faulty logic. Even though those look like they're congruent, they would have had to tell us up here that EG is also an angle bisector of FEH. But they didn't, right? They didn't tell us that. So that is how his proof is wrong. Even though it looks correct, since we don't know it for sure, we can't say that it's true. We can only say what we know for sure. And then it doesn't matter what he says after that. Once you have something wrong, it's wrong. Okay, so we know that step 3 there is wrong. All right, so that was all of Unit 2, Lesson 10 practice problems. Go ahead and take your quiz.